beneficial for us to talk about these questions. Let me unfreeze the screen. Here we go. So these are like questions 24, 25 from last night's homework. I just want to talk about them because, again, it's going to kind of reiterate, and I know you've heard me say this, but when we're dealing with problems in geometry, we have to be able to decide what's important, what's not important. I think a lot of people have been coming to me or they've been working with others, and I'm hearing that I don't even know what to do at the beginning, okay? You can't just look at this problem or this problem and right off the bat, if you struggle, to make the right connection, okay? Some people can look at this and instantly know what they need to relate to one another and how to set the equations up. But if you're not that person, if you're struggling with that concept right now, how do you approach them? Okay, my suggestion, I'm not saying it's right or maybe the only way of doing it, but it works. My suggestion, if they say, how do I show M parallel to N? What value of X do I need to have? I know I got to deal with those two lines. So I'm going to draw my attention to them. So maybe I redraw the picture. Okay, and just what I've been doing with you guys, because it just makes it a little bit easier, is to just highlight them. Okay, if you're using crayons, colored pencils, highlighters, whatever, do that. Okay, and the next thing I'm going to do is, okay, those are important to the problem. Obviously, this angle here is probably important to the problem, or has the potential to be important to the problem. This one here has the potential of being important to the problem. And this one here has a potential for being important to the problem. So I highlight those. Okay? Now I think about what have we been doing? We've been working with parallel lines and transversals, looking for same side interior, looking for corresponding alternate interior, alternate exterior, those types of angles. So I'm going to look at these transversals. We're trying to make this a simpler problem. Which transversal, based off of the idea of one of them helps create most of our angles, which transversal is probably most beneficial here, S or T? It's going to be T. Okay? Now, just if I look at S, it only makes that angle, but it really doesn't make all of that angle, right? I still need that transversal to make all that 45x, right? Does that make sense, everybody? So even though that red transversal S does help create part of, or one side of this 25x, it doesn't help do anything else. And I need two angles in this process to make a relationship, right? So the suggestion is that T is the better transversal to look at. I highlight T. My hopes are that you guys see that you no longer need this transversal here. If I don't need that transversal, I'm not going to need the 25x. It's just really confusing. Now you have these two things. Now they're not directly related to one another because one's an interior angle, one's an exterior angle, and they're on alternate sides. Okay? Well, this 16x, can that be replaced right here? Or transferred to right there? And now what is the argument between that angle and that angle? If I want M to be parallel to N. They need to be same side interior, so they have to be supplementary. So 16x plus 14x, and that will total 180. Gives me 30x equals 180. And then x will end up being 6, right? Does that make sense? And now you can plug that stuff back in. You can plug it back in here and say, okay, well, x is 6. Then this would be 84. This would here be 96. 84 plus 96 do indeed give me the 180. Okay? So it's all about highlighting or drawing your attention to the parts that are useful. 25x, do we ever use that? No. Okay? Because it doesn't have any relationship to anything else in this problem. Okay? Huh? I do.
tagging those. What if somebody makes a joke and you snort them up?
Oh my God. I mean,
What?
Yeah. So I'm actually, and I'll put to the point where it doesn't even come.
Or it gets lodged up there, it grows bacteria, and you die from it.
You know, it's not pros and cons.
Pros and cons, yeah. Okay, so, this question. This is a similar approach, similar idea, okay? We have these two lines M and N, and we're trying to make them parallel, okay? So my attention there. Now, which transversal do you guys think is going to be beneficial in creating a majority of the angles that we have present there?
D.
Okay, D, okay? So if I do that, so I draw my attention to that, maybe erase this, okay? My hopes are that you guys see that this 5x, which would have been that arc, or sorry, that angle right there, right? That doesn't have any relationship to the 3x to the 5x plus 44, because it's not an angle created by a parallel line and transversal, right? So we have to be able to decipher that. We have to be able to get rid of the stuff that we do not need. And now, can I take this 5x plus 44? Just like the last question, right there. And now, what would be the link between these two? And so in here, so if the lines are going to be parallel, they have to be supplementary. So I'll let you go through the work here on your own algebraically, but that should give you x to be 17. And then you can plug that stuff back in and find those specific values if you need. That will force N and N to be parallel. Okay? Yeah. All right. That's, and you've heard me say it several times earlier in the week. You heard me say it last week. That's going to happen all the time throughout the class. We're going to start talking about triangles in the next couple days. And when we start talking about triangles, it's not hard individually with just one triangle. So what they start doing is they start making multiple triangles, overlapping each other, attached to one another. And we have to be able to decipher what's important to us, where our information is being presented, where we start, and then kind of use our theorems to allow the process to kind of unfold itself. But what is